Hello everyone, this is Arpita and you're watching my channel Arpita Brijesh. In my today's video, I'm gonna explain what is a least recently used algorithm, which is a page replacement policy. So here we are given a reference string. All these are a reference string. These are a pages which a CPU wants to refer them. And here this is a frame size 3. So according to the frame size, we are going to divide a main memory into a frames, and since it is 3 here, I have divided a main memory into 3 frames. So now let us see how to do this. And before going ahead, let us see what is a least recently used algorithm. So in a least recently used algorithm, the page that is least recently used is going to be replaced whenever there is a immediate reference to be done with the page that is not present in the main memory. So here we come across two things. One is page fault. The page fault occurs whenever the page want to be referred is not present in the main memory and it should be brought from the disk into a main memory. So we call it as a page fault. So that will be represented and with this symbol here. And one more is page hit. So the page hit is whenever the page to be referred is present already in the main memory, we consider that as a page hit, and in this algorithm I am going to represent it with this symbol. So now we'll see that how to be done. So here we have a page 1 to be serviced first. So you can see here you don't have any pages in the main memory. So first what we do is we are gonna accommodate this page into the frame. So here I'm gonna accommodate this page 1 into the frame 1. So this is a page fault because it's not present in the main memory. And next page to be serviced is page 3. So we also know that page 3 also is not present in the main memory, and hence it should be brought from the secondary into the main memory, and it is also a page fault, and I'm going to represent it with this symbol, and it is 1, and in the frame 2 we are going to occupy page 3. So next page to be serviced is 2. So again we see that page 1 is occupied, frame 1 is occupied with the page 1 and frame 2 is occupied with the page 3, and page 3 is vacant, there is nothing. So let this page 1 be occupied in the frame 3. So it will be 2 here, 3 as it is and 1 as it is, and this is also a page fault. So the next page to be serviced is 4. So now we check here, we had only 3 frames, frame 1, frame 2, frame 3, and all these frames are occupied by page 1, page 3 and page 2. So the next page to be referred is 4, and it doesn't have a space in the main memory. Here the replacement is needed, and how we have to replace it? By using a least recently used algorithm we have to replace. So according to least recently used algorithm, the page that doesn't need to be referred immediately in a coming future, that need to be replaced. So now how we will get to know which page to be replaced and which is not recently, which doesn't need an immediate reference? That is how based upon LRU, that is least recently used, which is used long back compared to the other pages. So if you want to replace if you want to put a page 4 into the main memory, you have to replace these 3 pages, because these are the 3 pages which are already occupied in the frames 1, 2 and 3. So when you check, you see that before page 4, page 2 was already serviced, and before 2, page 3 was serviced, and then 1. So when you compare these 3, page 1 was the least recently used page, and hence in place of 1 we can replace 4. So hence it is 4 here in the frame 1, and then 3 and 2 as it is. And this is also a page fault since it was not present, page 4 was not present in the main memory. So next we go to a page 2. So when you want to bring a page 2 into the main memory, you check the page 2 in the main memory. You want to service a page 2 and the page 2 is being checked in the main memory. When you check in the main memory, already page 2 is present in the frame 3. So you need not bring it from the secondary storage. Already it is present in the main memory. So we copy it as it is, and this is considered as a page hit. So next page 1 need to be serviced. So when you want to service a page 1 and it is checked in the main memory, it is not available, and hence there is a need to replace any page. So which page to be replaced we see here. So there are 3 pages, and you can see before page 1 that was 2 which was recently serviced, and page 4, and then comes page 3. So when you compare 4, 3 and 2, 2 was immediately serviced, and after that 4 was done, and then before these two, 3 was serviced, and hence page 1 will be placed in place of 3, and then 4 and 2, and this is a page fault. So next comes a page 5 which should be serviced, and when you check here, the page 5 is not present, and hence it is a page fault, and we need to replace a page. So which page to be replaced? You have 3 pages here, 4, 1 and 2, which are in the main memory, and if you check here, before 5 it was 1 which was recently serviced, page 2 before 1, and page 4 prior to these two. So hence page 4 will be replaced by page 5. So this is 5, and here 1, and this is 2. So this is a page fault. So next we are going to service page 1. So when you see page 1, it's already present in the main memory, and hence it is considered to be a page hit. So we copy all the pages as it is, and this is a page hit. So next page 3 should be serviced. So now you can see there is no page 3 in the main memory, and hence it should be replaced by in place of some page. So which page to be replaced, we'll see. Page 1 was just serviced before 3, and 5 was serviced, then 2 was serviced. So here 2 is the one which was least recently serviced, and hence page 2 is the one which will be occupied by 3. So that is, this all will be copied as it is. So hence it was a page fault, and I have represented it with this symbol. So next page to be serviced is 2. So we can see again we don't have a page 2 in the main memory, and hence it should be replaced in place of some page. So which page it should be? We see 3 is just recently serviced, then 1 and then 5. So when you compare these 3, you see that was 3 first serviced, just serviced, and 1 was serviced, and then 5. So 5 was serviced before 3 and 1, and hence this was least recently used. It was not a recent page that was serviced, and hence the 2 will come in place of 5. So 2, 1 and 3, and this is a page fault. So next page to be serviced is 6. So you can see there is no page in the main memory, 6. So hence it should also be replaced. So when you see which one has to be, 2 was recently used and 3 was recently used, before that 1 was used, and hence in place of 1, 6 will be occupied. So again this is also a page fault. So next page to be serviced is 3. So we see that 3 is already present in the frame 3. So you need not replace any page. So just copy the same pages, and this is a page hit. So next page 5. So page 5 is not present in the main memory, and you need to replace in place of some page. So which one? Out of these 3 pages, 3 was just serviced before 5, and then 6, then 2. So among these 3, 2 was least recently serviced, and hence in place of 2, 5 will be occupied, and all others will follow as it is, and this is a page fault. So next page to be serviced is 4. So again we check here, 4 is not present in the main memory, and it should be replaced in place of some page. So serviced, and first next it was 3, prior to it was 3, and then it was 6. So compared to these 3 pages that are present in the main memory at present, so 5 was recently done, and before that 3 was done, and before that 6 was done. So 6 was the one which was least recently serviced. So in place of 6 we are gonna replace 4. So this will follow as it is, and hence this is the next page to be serviced is 3. So you can check serviced is 3. So we are going to see here in the frames. So 3 is already present in the main memory, and we need not replace it with any page, and hence it should be copied as it is, and this is a page hit. And then the next page to be serviced is 2. So you see there is no page in the main memory, which is 2, and hence it should be replaced by some other in place of some other page. So which page it is, we'll see. So here in the main memory we have 5, 4 and 3 which are already been occupied, and we will check which is least recently used. So before 2 it was 3 which was just serviced, and then 4, then 5, and then 5 will be a least recently serviced page, and hence in place of 5 we are going to replace page 2. So all others will follow, and this is a page hit. And then the last page which need to be serviced is 4. So hence 4 is already present in the main memory, and hence it is a page hit, and we need to just copy them as it is, and this is a page hit. So now when you see this, after doing this, you will be asked actually to calculate what are the number of page faults and how much is a page hit. So now out of all this, how many page faults we have got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of page faults are 12. And how many number of page hits we have got? So those are 1, 2, 3 and 4. Sorry, 1, 2, 3, 4 and 5 we have. That is 5 you can write. So hope you have understood this, and if you have any doubts you can leave it in the comment section, and I'm sure I'm gonna get it back on this. So if you're new to my channel, please like and subscribe my channel. Thank you for watching.